Okay, I feel a little bad about the lecture this morning, so I wanted to redo this problem because it is a tough one and very important for understanding vectors. So what we want to do is we want to figure out the moment of this force with respect to the line going through AD. So it's not the moment around the XYZ direction, it's the moment of this force trying to bend this frame around the direction AD. In the past, what we've done is the moment in the XYZ direction. So when we crank through a cross product, so we go from an axis of rotation to an applied force, and this point A, it is on the axis of rotation here. So if you crank through this, what you get is you get a moment in the K direction. So you can wrap your fingers around the Z axis here, and you can see that it's going back into the screen. So negative 100, and this moment is in the K direction, but we don't want it in the K direction. We want it around this axis of rotation between A and D. Or like, here's another scenario. So let's say I figure out the moment around point D. And if I just plug in, let's see, my position vector here is 0.75 in the K direction, and it's going out to a force, let's say 100 pounds going straight down. If I look at this moment, it is wrapping around the X direction this time. So again, use your right hand rule, curl your fingers around, and the moment is a vector along the x-axis describing that axis of rotation. Okay, so, but we don't want the moment around the z-axis. We don't want the moment around the x-axis. We want the moment around this AD direction, and that is where a dot product comes in. Before we can use a dot product, we need to get the unit vector of what AD is. So to get the unit vector, that's the fraction of this vector in the x, the y, and the z direction, okay? And you can kind of curl your fingers around and see which way this arrow is going to be pointing. The dot product is not going to give us a vector, just a magnitude. So the direction you will have to get off of a picture. You won't be able to get it from the dot product. Dot products have no direction. Okay, so drawing this picture, and you can see we're going back in the z direction, 0.75. We're going forward in the x direction, a distance of 1. So here's the overall distance from A to D is 1.25. And if we take these fractions, so how much is in the x direction, and then there's nothing happening in the y direction, and then the z direction. So here is our unit vector. So that describes the fractions in the x, y, z direction for this AD line that we're interested in. So the next step is we're going to take this unit vector and we are going to use a dot product with our previous moment. And this is going to get us the piece of this moment that is in the same direction as our unit vector. So if you take a vector, right, and you can break it into components, how much of this 100K vector, this moment around the z-axis, part of it is in the same direction as AD, and part of it is perpendicular to AD. The perpendicular piece, that's cross product. The parallel piece, this part that's in the same direction, that is the dot product. And to get the dot product, what I need the unit vector for which direction I'm trying to go in. I need my moment mapped into x, y, z components, and I'm going to use a dot product between that unit vector and the moment. So that's the 0.8 times 0. It's x times x plus y times y plus z times z. And you can see if I add all of those, x times x plus y times y plus z times z, if I add those guys together, I get a magnitude of 60. So of those 100 Newton meters, 60 are in the direction of this line AD. What if I did this from the other direction? Okay, so here is R cross F. This is the moment around the x-axis, right? And it was a different value, it's a different length of the lever arm. So if we crank through going from D to point C, so this is 0.75 in the K direction to that 100 pounds hanging off of here. So we end up with a positive 75 in the X direction moment. And once again, I'm going to take that moment, that 75, and I'm going to see, okay, how much of it is perpendicular versus how much of that 75 is in the same direction as AD. And I can go through the same thing, right? So if I take the unit vector for AD, so there's a unit vector for AD, and I crank through x times x, y times y, z times z, I end up with, it's the same magnitude. It's the same magnitude. So for these problems, what you want to do, it doesn't matter kind of where you start taking the moment around. Starting from A or starting from D, I just have to go from some point anywhere along this axis that we're interested in, any point will do, from that axis of rotation to where that force is applied. And then I'll go one more step and I'll take that moment, so the 100K or the 75, I'll take that moment and the dot product will get me the amount that is in this new direction. Okay, hopefully that was a little bit better. Sorry if that was confusing this morning. I was kids and dogs and hubby's at jury duty, so lots of chaos going on. But yeah, that's the point of a dot product. So a dot product, if I want something not in the X direction, not in the Z direction, I want it around some new crazy direction. What's the twist around this axis? Use a dot product. And you just have to get the unit vector, and you get the unit vector going in the direction you're interested in, and then you take that unit vector, you multiply it by your moment. This works for forces, it works for velocities, any kind of vector this will work in. So instead of having something in the X, Y, Z direction wrapped around the Z axis, you can then find, okay, what's that same thing? What piece of it is wrapped around this other axis instead? So you can take a vector and you can kind of see how much of that vector is in any direction you want if you just have the unit vector for that. So instead of X and Y, tangent, normal, you can take any vector and map it into how much of it is along the same direction that you're interested in.